You know, when I was a kid, we used to go camping far away from the city. And when you'd look up at the night sky, you could see so many stars.
Yeah, stargazing is hard in the city. There's just too much light. I saw the Milky Way once.
Cool.
Yeah, we were out in the desert, and you couldn't even begin to count the stars. It was amazing.
You know, scientists have estimated there to be 10 to the 11th stars just in our galaxy. If every person on Earth counted just 15 different stars, we could count them all.
Every person?
Yeah.
That's 7 billion people counting 15 stars each.
Wow, I never said it was going to be easy. You know, scientists have also estimated there to be 10 to the 24th stars in our universe.
Well, in that case, each person would have to count 150 trillion different stars.
You know what? We're going to have to use scientific notation because the numbers are just too big to imagine, let alone count.
Okay, so that's 10 to the 24th divided by 10 to the 11th means that there could be 10 to the 13th galaxies like ours.
That is 1,000 galaxies per person.
You know, I wonder if there's anyone out there looking into their night sky back at us.
You know, a lot of people have wondered that. You ever heard of the project called SETI? The Search for Extraterrestrial Intelligence? Yeah, it's based on an experiment from the 60s that was started by a man named Frank Drake out of Cornell University.
Yeah, I've heard about SETI. They listen to radio signals from space, right?
Yeah, and the Earth gives off so many signals, from radio to television, for example. And the idea is that hopefully extraterrestrials use a similar type of technology.
And what are the chances that we'll actually hear them?
Well, you know, Drake worked out an equation to give us a pretty good chance. Should we take a look at it?
Yeah.
Okay.
Okay, so explain these factors to me.
Okay, so our star is the average rate of star formations in our galaxy. And NASA has estimated that to be about 7 stars per year.
And the rest?
So, the F factors are all fractions of the preceding factor. So F sub P is the fraction of stars that have planets. F sub L is the fraction that develop life. F sub I is the fraction that develop intelligent life. And F sub C is those that communicate in a way we can detect.
Okay, so far so good.
N sub E is the average number of Earth-like planets that can support life. And L is the average lifetime of communicating civilizations.
So do we know any of these numbers?
Yeah, well, scientists have a pretty good estimate on some of them, but others still remain a mystery. They think they have a pretty good handle on F sub P.
Oh, so the percentage of stars that have planets.
Yeah. Current evidence indicates that F sub planets is probably 100%.
Well, in other words, most stars have planets.
Yeah.
Wow.
Yeah, pretty wild. But F sub life and F sub intelligence still awaits more data. Currently, we only know of one civilization that has intelligent life. Earth. Exactly.
That's what I thought.
But let's face it, we've only explored just a couple of planetary systems, the Earth-Moon system and Mars.
What about N sub Earth light? There's been a lot of research on that lately, right?
Yeah, the Kepler Space Telescope has been looking for new planets since 2009.
Yeah, I've heard about that. They've discovered over 4,000 planets, right?
Yeah, and there may be as many as 4 times 10 to the 10th habitable planets in our galaxy. That's out of 10 to the 11th stars, so N sub E might be something like 0.4.
Imagine that. 40% of the planets in our galaxy may be Earth-like.
Yeah, makes you want to go visit them.
Well, okay, so let's assume the F factors we don't know are 0.1, equivalent of 10%.
Okay, so 7 times 1 times 0.4 times 0.1 times 0.1 times 0.1 times lifetime.
Right, so that would be 2.8 times 10 to the negative 3 times lifetime. But lifetime is really difficult to estimate, isn't it?
It is.
Who knows how long a civilization might last?
Well, Carl Sagan in his Cosmos series said that that right there is the single most important factor, not to mention the hardest to calculate. But again, we only know of one intelligent civilization, so we just need more data.
Well, if a civilization lasts only 10 to the third years, there might only be 2 or 3 civilizations in the galaxy at a time.
But if it lasts 10 to the 4th years, there could be 30 of them out there. And there's 10 to the 13th galaxies in our universe. So there could be trillions of civilizations out there right now. And, you know, maybe they're out there looking for us too. Fingers crossed, right?
I see one.
Enid, don't do that.